Let's show a mechanism of the hydrohalogenation reaction on screen. The first thing we notice is that we're going from a 4-membered ring to a 5-membered ring, and so it seems clear that there's going to be some rearrangement that happens in this reaction. The reaction is going to start by protonating the alkene with HCl, and when we do that, we'll end up with a carbocation that is secondary. Now we note that this secondary carbocation is next door to a quaternary carbon. Anytime the carbocation is less substituted than its neighbor, we anticipate a rearrangement occurring. What rearrangement should occur? Because we could have a methyl group move or we could expand the ring. The product gives us that answer. It says that because the ring has expanded, that's going to be the one that happens. In real life, it might be a mixture of both, but for this particular problem, we need to show a mechanism that has the ring expanding. We can also justify why the ring expanding would be better, because going from a 4-membered ring to a 5-membered ring is going to probably result in greater stability. So let's show that rearrangement. That alkyl group shifts over. That's going to give us a 5-membered ring, where we now have this methyl group is this methyl group. This one here is now the carbon that has a positive charge. When we protonated the alkene, we also produced HCl. Now we're going to see that Cl- come back into play, where Cl- can now donate a pair of electrons to the empty p orbital of the carbocation, and that's going to complete formation of the product.